Today we are going to discuss about the properties, the uses of graphite and diamond according to their bonding and structure. Here you can see one carbon is attached to four other carbons in the structure of diamond, which shows diamond is making a tetrahedral geometrical structure. Instead of it, in a graphite, one carbon atom is attached with the three other carbon atoms. That's why graphite is making a trigonal planar geometric structure. One carbon is attached with three other carbons, making one double bond and two single bond. They both are basically the allotropes. Allotropes are the elements having two or more than two physical states. Both diamond and graphite are made up of carbons having a structure that is completely made up of carbon but having different physical states. That's why they both are called as allotropes of each other. Diamond having tetrahedral geometry having a 3D structure and graphite having a trigonal planar geometry 2D structure. In diamond, you can see all bonds are single bonds. All bonds are sigma bonds. There is no double bond. So all the bonds are sigma bonds. Sigma bonds are single bonds. But in a graphite, you can observe both sigma and pi bond. Double bond is also called as a pi bond. Pi bond. In a one double bond, there is one sigma and one pi bond. So in graphite, one carbon atom is attached with three other carbon atoms, making three sigma bonds and one pi bond. Carbon is basically an insulator. Do not conduct electricity. As we have discussed that graphite, diamond, silicon, the giant covalent compounds having a high melting and a boiling point because of their giant structure, because of their lattice structures. Diamond is insulator, do not conduct electricity and heat. Insulators are those who do not conduct electricity and heat. Why diamond do not conduct electricity? Because diamond do not having a free electrons and any ions. For the conduction of electricity, it is important that material having free ions or material can make ions. But diamonds do not contain this property. Diamond do not having any free electrons or ions in its structure. There is a complex structure of diamond. All the carbon atom, the tetrahedral geometric carbon structure is tightly packed. There is no spaces between when all the carbon atoms are tightly interlocked with each other. That's why there is no freely moving electron. That's why there is no conduction of electricity in diamond. But there is a conduction of electricity in graphite because of the pi electrons. There are freely moving delocalized electrons in the structure of graphite. Due to that delocalization or the freely moving electron in a graphite structure, graphite is a conductor of electricity. Here you can see the structure of graphite. Graphite, one carbon atom is attached with the three other carbon atoms. In this way, they make a hexagons. All the hexagons are attached with each other. 6 carbon structure, cyclic structure is basically a hexagonal structure. So graphite is making a layers. Between these layers there are weak intermolecular forces. Due to these weak intermolecular forces, graphite is soft. Due to the hard interlock structure of diamond, diamond is hard. Because of the interlock structure, because of the strong covalent bonds, all the bonds in the diamond are covalent bonds. Here you can see one carbon atom is attached with the four other carbon atom and and they having a covalent bond. Covalent bond is formed by the sharing of electron. So diamond having a covalent bond. Covalent bond is very strong bond. If you want to break the covalent bond, you need a high amount of energy. So due to this hard structure of diamond, hard structure of diamond is used as a tool. Tool that is used for cutting. You can cut the hard materials by the diamond. For example, rocks. Rocks are very hard, but you can cut the rocks with the help of a diamond. But instead of this, graphite is a soft because of the free electrons. Its structure is very soft and slippery because of the free electron between the layers. Graphite is a slippery. Graphite is present in your pencil, and when you write with the pencil on your notebook, due to the slippery nature of the graphite, you can easily write on your notebooks. In the layers of the graphite, carbonic layer, the one carbonic layer and the another, between them there are weak intermolecular forces. So when you press with the pencil, the graphite help to write you and slips on the paper. Graphite having a colorless, diamonds are colorless. Graphite having a black color. For example, your lead pencils are of black color, grayish black color. Density of diamond is 3.5 gram per ml and density of graphite is 2.2 gram per ml. So the difference of the density is also explaining that the diamond is hard. Next, you can convert the graphite into diamond. Nowadays, chemists can make the synthetic diamond from graphite. As we know, the diamond is a very expensive. We can make synthetic diamond from graphite. How we can make it? By high temperature till 28,000 degrees Celsius. As we know, water boils at 100 degrees Celsius and we can feel the temperature is very high. So 28,000 degrees Celsius, you can imagine that this temperature is very, very high. This temperature is used to break the pi bond and a sigma bonds of graphite. As we have discussed, there are pi and a sigma bonds in a graphite. So due to that much of heat, you can break pi and a sigma bonds. If you want to convert this graphite into diamond, you need 28,000 degrees Celsius temperature and 150,000 atmospheric pressure. So you need a high temperature and a high pressure. Then you can easily convert that graphite into diamond. You have to keep that pressure and a temperature for 24 hours. 1 atm is equals to 101300 Pascal. So you can imagine that this atm is in a Pascal having a very high value. Next is, what is the similarities between the diamond and the silicon dioxide? Here you can see the structure of diamond and silicon dioxide. In a diamond, one carbon atom is attached with the 4 other carbon atoms. And this same structure is repeated again and again. Each carbon atom again attached with the 4 carbon atoms. In this way, the structure repeats itself. Due to the strong covalent bond in a diamond, due to the interlock structure of diamond having a high melting and a boiling point. Because of the strong covalent bonds, you need a high amount of energy to break this. In the same way, One silicon, this black dots are represented as a silicon atom. One silicon is attached with the 4 oxygen atom. These blue dots are representing oxygen. So silicon dioxide having a approximate similar structure to the diamond. One silicon is attached with the 4 oxygen, and then again one silicon is attached with 4 oxygen atoms. Silicon having a high melting and a boiling point as diamond having, because they having a similar tetrahedral structure. Both having tetrahedral structure. Both having high melting and a boiling point, and all the bonds in a silicon dioxide, in a silica, then another name of silicon dioxide is silica or sand. So due to all the bonds of covalent, silicon dioxide having a high melting and a boiling point. Here you can see the structure of diamond and graphite. Hexagonal layers of a carbon and the spaces between them, these spaces having a free moving electrons. These layers attach with each other with the weak intermolecular forces. Weak intermolecular forces. In this graph, in this table, you can say, I'm going to explain you all the properties of diamond. All the atoms in a diamond are carbon atom, 100% carbon atom, no any other atom. All the bonds are covalent bonds, and covalent bonds are very strong bonds. You need a lot of energy to break these bonds. Strong covalent bond. A covalent bond that is very, very strong. If you want to break this bonding, you need a very high amount of energy. This is a giant covalent structure, 3-dimensional structure. All the carbon atoms as a tetrahedral structure attached in a 3D directions. That's why due to this 3D structure, due to this giant covalent structure, diamond is very, very hard and having a very high melting and a boiling point. If you want to do a hole or to break a rock, the drills are used at the tips of these drills. Diamond is attached because diamond is used as a cutting tool. So by using diamond at the tips of the drills, you can make the holes on the rocks. Next, here are some properties of silicon dioxide. Similar properties of silicon dioxide and diamond are both having a giant covalent structure, both having high melting and a boiling point, both having a similar structure. In diamond, one carbon attached with the 4 other carbon atoms. In a silicon, one silicon is attached with 4 oxygen atoms. Both are insoluble in water. Diamond is also insoluble in water, and silicon dioxide is also. If you are taking water in a beaker and placing diamond for many days, it will not be soluble in this water. So silicon dioxide and diamond are insoluble in water. They both, silicon dioxide and diamond, both do not conduct electricity because both do not having a free electrons or any type of ions.